If you're going to master just one command in Docker, this is the one. Docker run. Seriously, it's the command that brings everything to life, turning a static image into a running, breathing container. So let's dive right in.
That's right, this is the moment you've been waiting for. It's time to actually run something. We're going to stop talking and start doing. In the next 10 minutes, we are going to master Docker run and all the essential flags that go with it. I promise, by the end of this, you'll be spinning up containers with total confidence.
So here's our game plan. First, we'll cover the rules of the game, the container lifecycle. You gotta know that. Then we'll get our hands dirty with our very first Docker run commands, and after that, we'll power them up with some essential options. We'll learn how to manage the containers once they're up and running, and finally, we'll put it all together in a hands-on challenge. Sound good? Let's go.
Okay, first things first. Before we start firing off commands, we need to understand the life cycle of a container. You can think of it like a character in a video game. It has different states. And trust me, knowing these states is the key to understanding everything that comes next.
A container really has 5 core states. It starts as created. Basically, it's all set up, but it's not started yet. Then comes running. This is the main event. The app is doing its thing. You can also pause it, which literally freezes it in time. Now, when its job is done or you tell it to stop, it becomes stopped. And here's the crucial part. A stopped container is still there. It's still taking up space on your disk. It is not gone until you explicitly remove it.
Now this is a core philosophy of Docker. You have to get your head around. Containers are meant to be temporary or ephemeral. When you remove a container, any changes you made inside it, poof, they vanish. Now that might sound a little scary, but it's actually an incredibly powerful feature. It guarantees that every single time you start a container, it's from a clean slate. This is exactly how we solve that classic, well, it works on my machine problem. We'll talk about how to save data permanently in a future explainer, don't worry.
All right, that's enough theory. Let's get our hands dirty and actually run a container. We're going to start with the absolute simplest command and build our way up from there.
This is the classic hello world of Docker. When you type this single command, Docker does all the heavy lifting for you. It checks if you have the hello world image, it pulls it from the internet if you don't, it creates a brand new container, runs it, prints out a success message to your screen, and then the container immediately exits. If this works, your Docker setup is perfect. It's an instant win.
Okay, now for something way more useful, getting a command prompt inside a container. For this, we use these 2 magic flags, IT. Just think of it like this. I keeps the connection interactive, and T gives you a terminal to type in. Put them together, and bam, they drop you right into a bash shell inside a completely isolated Ubuntu system. Go ahead, try running ls or cat/etc/os release. You'll see you're in a whole different world.
So what about long-running services, like a web server? We obviously don't want them tying up our terminal window. For that, we use the D flag, which stands for Detached Mode. This starts the container in the background and immediately prints out its unique container ID. The container is now running happily in the background, and you've got your terminal back.
Okay, so we can run containers. That's awesome. But how do we make them truly useful for a real project? Well, that's where we add a few more essential options, or flags, to our Docker run command.
You know, dealing with those long, random container IDs is a real pain. The -name flag is a lifesaver. It lets us give our container a simple, human-readable name like my_nginx. This makes it so much easier to manage later on when we want to stop it, or check its logs, or connect to it.
And this is one of Docker's superpowers, port mapping. See, a container has its own private, isolated network. The P flag builds a bridge, a tunnel from a port on your computer, our host machine, to a port inside the container. So in this example, any traffic that hits port 8080 on your computer gets forwarded directly to port 80 inside that nginx container. So what does that mean? You can now open a browser to localhost 8080 and boom, the nginx welcome page is right there. Just like that, you have a web server running. So how do you actually configure an app running inside a container? The most common way is with environment variables. The -e flag lets you inject configuration, things like database passwords or API keys, at runtime without ever having to touch or rebuild the image itself. It's super flexible. Okay, here's a pro tip I use all the time. Remember how stopped containers just hang around on your system? Well, if you're just running a quick task or a test, add the -rm flag. As soon as that container's main process exits, Docker will automatically clean it up and remove it completely.
This is fantastic for keeping your system tidy and preventing a buildup of old, stopped containers.
So, we've got containers running in the background. We've given them nice names, and we've exposed their ports. Now what? How do we interact with them? Let's look at the essential command toolkit for managing the lifecycle of your containers day to day. Think of this as your daily toolkit. Docker PS is how you see what's running. Stop and start are your basic on-off switches. Logs is absolutely essential for debugging. It lets you see what your app is doing. exec lets you jump inside a container that's already running, and RM is for cleaning up when you're all done. Let's zoom in on two of the most important ones.
Now, this is a classic spot where beginners get stuck. You run Docker PS, and you only see your active running containers. You might think your other containers have just disappeared, but they haven't. They're just stopped. To see all of your containers, both running and stopped, you need to add that little -A flag. And this is another absolutely critical distinction. Just burn this into your brain. Docker run creates a new container every time. Docker exec lets you run a command inside an existing already running container. So if you want to debug or inspect something that's already running, exec is the tool you need.
Okay, we have covered a lot of ground, and honestly, the best way to make all of this really stick is to put it into practice. So it is time for a hands-on challenge. Are you ready for this? I want you to open up your terminal right now and try to complete these next few tasks.
Okay, here is your mission should you choose to accept it. 1. Run a detached Nginx container, give it the name web server, and map your local port 8080 to its internal port 80. 2. Verify that it's working by visiting localhost 8080 in your browser. 3. Check its logs. 4. Use exec to get a command shell inside of it. And finally, number 5, stop it and remove it. Go ahead and pause this explainer right now and give it a shot.
Welcome back. So, how'd you do? Let's walk through the solution together. First, we use Docker run with the D flag for detached, name to call it web server, and P to map the ports. Simple enough. Next, we check the logs with Docker logs web server. Then we jump inside with Docker exec IT web server bash. And finally, we clean everything up with Docker stop and Docker RM. If you got all of that, you are in fantastic shape.
Let's just do a quick recap. The key flags you've got to remember are D for detached, IT for interactive, P for ports, E for environment variables, and -name for easy management. Remember the lifecycle. You run, stop, start, and eventually remove your containers. And please, don't forget that -RM pro tip for one-off tasks. It'll save you so much cleanup later. Seriously, with just this, you now have the foundational skills to run almost any containerized application out there.
So, what's next on your journey? Well, don't stop here. For a little extra credit, challenge yourself to run a Redis container and map its port. And get ready, because in our next explainer, we're going from running other people's images to building our own custom images with a Docker file. Thanks so much for joining me on